Well, good afternoon and welcome to this GIRI forum where we're looking at the importance of getting passive fire protection right and how to go about it. This is perhaps one of the more technical webinars that GIRI has sponsored, which moves away slightly from our more cultural and behavioural type approach, but it's nonetheless important. And the GIRI Building Safety Act steering group has a particular interest in this passive fire protection. I'm going to give a short introduction about GIRI for those of you who are not familiar with us, and then hand over to Craig Wells of Quell Fire, who's going to deal with the substance of the subject, and then Rob Hatchett from Ashe will touch on the importance of early design consideration when we're thinking about fire protection. And we'll follow that with a Q&A session to pick up any queries or comments that you've raised. On the housekeeping front, can I ask you to mute your microphones if you're not speaking, but remember to turn back on if invited to ask a question. And if you don't mind leaving on your video, because that way we feel the meeting has more vitality. And please use the chat box for questions and comments as we go through that we can consider in the session at the end. If you have any technical problems, the usual IT advice: turn off and try again, i.e. leave the meeting and rejoin using the same link. So about GIRI. In 2015, we carried out a research project in which we were looking to establish what the root causes of error were and how much do we waste as an industry. We had contributions from many organisations who were willing to share their information with us, and this is what we found. This chart shows what we found in respect of spend on error. The cumulative wasted spend is 21% of turnover. The 5% direct cost is what we all see, NCRs and tablet records, etc., but much of the cost is hidden. There is 7% of indirect costs, the impact on others, particularly in terms of delay and disruption. 6% of unrecorded process waste, where we have errors made and hidden or corrected but not recorded. And 3% the latent defects which manifest themselves after handover. Now, profitability in construction generally hovers at around 2 or 3% of turnover. So we can quickly see that the spend on putting things right is an order of magnitude higher. And even if there are questions about the accuracy of the findings, there is a clear imperative to avoid error. The research concluded that these were the top 10 root causes of error, and GIRI's activities following the result of the research have been targeted on these highest ranking causes: planning, design changes, information, culture, financial and time pressures, and supervisory skills all feature in this list. GIRI was established following the original research as a not-for-profit membership-based organisation with the strategic aim of improving industry productivity through the elimination of error, and we became a limited company in 2017. The research demonstrated the link between error elimination and productivity, and this helped to convince businesses in the industry as to the benefits of investing in a zero-error program. But the world is changing, and boardrooms are now recognising the broader range of imperatives they need to satisfy, including safety, sustainability and quality. An error-free strategy provides a platform for achieving all these objectives, and our strategic aim now reflects this. So let's take a quick look at how GIRI is going about seeking to achieve its objective and the many benefits that such an approach brings. We have our thought leadership through training, campaigns such as our framework, and forums and webinars such as this. And then in terms of knowledge sharing, we have our research, much of which you'll find on our website, both in terms of design and technology. We are very active on social media, and we provide networking opportunities for our members through 4 meetings in London, usually per annum. So what are the benefits? Well, productivity certainly is a big gain if you're not wasting time and money. Safety, research in Australia found that 37% of accidents occur during rework. So if you're not making errors, you've got a safer site. And in terms of sustainability, if we're not wasting, as I said before, then our carbon footprint is going to be better. I think the quality benefits are manifest if you get it right first time. And in terms of predictability, if we are not wasting that time, money, and effort, then our outcomes are more predictable. And overall, both as organisations, companies, and the industry as a whole will have a better reputation. Our training comprises 4 courses: leadership training, interface and design management training, supervisor and manager training, and trainer training. These courses are all CITB accredited, so levy payers can get grants for you attending our courses, and there are discounts for members. Group of members back in 2018 started thinking about how design was such a major impact on being the root cause of error, and we produced our GIRI design guide, which is available through our website, and I highly recommend you dip into that. We have a number of working groups, the insurance, technology, metrics and steering group, BSA steering group. The BSA steering group looks specifically at the Building Safety Act, and it's through their work that we've come to this webinar today, along with the request for more input from Ashe Construction. We've got a number of collaborations across the industry with a variety of other industry bodies focused on industry improvement. So we need to have the right culture throughout the industry so that people feel empowered to act in ways which reduce error. And that's to the benefit of those in the industry and those who live and work in the buildings and infrastructure we create. So we need to change the way we work and behave now. And if we do that, we'll have an industry that is more cost effective and has a better reputation. So let's hear from Craig about passive fire protection.
Thank you very much, Cliff. That's excellent insight into the wonderful work that you're doing as an organisation, and certainly the message that I'll be sharing today links very much with those core objectives. So yeah, my name is Craig Wells. I am the Sales Director at Quailfire. I'm very passionate about life safety, particular fire safety. So I'm going to be trying to cram a lot of content into a short period of time. But if we first of all just start off by saying, well, what is passive fire protection? It's often the unseen and the unsung hero. And it's just one of the elements of the fire safety requirements. So we see the active, the alarms and the sprinklers and the extinguishers on a day-to-day basis. Passive fire protection often hidden away within the fabric of the building, but just as important. So what we're talking about is really compartmentalizing the building and breaking the area down into areas of manageable risk. But of course, in order for that building to function, you're going to have necessary weaknesses within the compartmentation. By weaknesses, we mean things like windows, doors, but in the context of today, surface penetration seals, so pipes, cables, and so on, necessary for the building to function, but ultimately breaching the compartmentation, so need to be suitably fire stopped. So I'm not going to go through lots of pictures of how to get it wrong. We can go to social media for that. I'm going to touch on a couple of examples just to kind of set the context. But this is very much about how you move forward from today, how you can get it right, and it does require, as we've said, a cultural change or a behaviour shift. So a real reminder, really, that fires do happen. Let us not think that it won't happen. It doesn't happen to us. Fires do happen, and we've had lots of high-profile cases in recent years. But what we can see here is, should we say, a typical building fire, but ultimately we can see the fire spreading from one compartment to the next. So pretty scary stuff. But ultimately, the nice thing about this, if we install the correct products in the correct way, the fire can be contained to the compartment of origin for the prescribed period of time for which it's been tested. So, how do we arrive at that situation where we install the correct products in the correct way? That's what we'll be talking about today. So, as promised, I'm not going to share lots of how not to do it pictures, but here is a problem. It's hopefully a fairly well-known problem. This is a fire-resistant expanding foam filler that's been squirted in around various services. The problems with expanding foam filler, hopefully, as I say, are fairly widely known, but ultimately the problem lies in the fact that we look at what it says on the tin or on the website or the product data sheet. What we need to be looking at is the tested scope of application of the product and system, and designing and planning the work in conjunction with that. So, as just in the same way as it's not a case of one product squirted in, it's not a case of saying, well, we'll just build an opening in a fire rated wall, we'll run all the services through and then rely on a fire stopper to come and put some product in afterwards. The fire stoppers are only installers of tested systems. So if they come to a situation like this where there's absolutely no consideration for the fire stopping, and they tell you, well, you've got to create the wall bigger, the aperture in the wall larger, you've got to move services, etc., they're not being awkward. They're trying to do it right. They're trying to install the product in accordance with the tested scope of application. So how do we get to that situation? It is a basic concept. It is design and then build, not build and then hope we can fit something in. So yes, identifying your services, designing it, spatial coordination, and then turning that into a real install. So if we think about service penetration sealing, what do we mean? Often we talk about, it's a batten mastic seal. So I think when we talk about culture change, behavior change, we actually need to start changing our language. So it's not just a bat seal. It's a number of products. It might include a fire bat, but installed as a tested system. So yes, there might be bat, but there could be wraps, there could be collars, there could be sleeves, there could be different types of sealant, and yes, bat and sealant as well. But it's a tested system. And of course, the fire stopping itself, only as good as the substrate that it's installed into. So it's relying, in this case, on the plasterboard, the dry lining. And of course, the services need to be adequately supported as well. And in terms of who's responsible for this, well, you might say, well, it's the fire stoppers problem, the end of the project. Yes, they take final responsibility, but there are a number of different people, different trades that directly impact the overall performance of this seal. So as we've said, the dry lining in this case, the creation of the aperture, the plumber, the electrician, the ventilation installer, the sprinkler installer, the lagger, and yes, finally, the fire stop contractor. But as I say, they are only an installer of a tested system. So it's important that there is coordination, communication across all the trades to ensure that they can install a tested system. So whilst it's, tempting to just look at the glossy product data sheets and the flashy websites or the label on the can, as we've said, it's very much about identifying the tested details, the standard installation details, which are based on the test evidence, which are specific to your set of circumstances. So how do we arrive at that? Well, we'll talk that through. Ultimately, those standard details will have a number of key requirements within that tested scope. Things like the fire rating that the detail provides, and then type and size and specification and spatial coordination, which will go on in the next couple of slides. So obviously there are limitations on the actual services themselves, the maximum size of bundles, the maximum diameter of pipes, the maximum thicknesses of insulation, and so on. So all these things need to be thought about. And then the actual seal around those services will vary as well. There could be different number of layers of wrap, might be 1, 2, 3, 6 layers. It could be that we're using a sealant. There might be a 10 mil annulus, a 20 mil annulus. So that's when I say annulus, it's the size of the seal around the services. So it's important we're looking at those specific standard installation details, which are based on test evidence, to identify, is the size of the service covered and what size seal does each of those services require. So there's an example of a standard installation detail, and as I say, could be a range of sizes of seals. Now, I appreciate a lot of information to take in one go, but just want to sort of kind of set the scene of how complex it could be. One of the bigger, wider issues that often gets overlooked is spatial coordination. So the space that is required between individual fire stop seals. So ESCN 1366 says, or part 3 says, that there should be 100 millimeters between each seal unless tested otherwise. So yes, you can have multiple services running through that hole in the wall, but you need enough space between them. Between the wrap and the sleeve, or the sleeve and the sealant, or the sealant and the sealant, 100 millimeters or as tested. So again, it's about that scope of application, that tested scope to say, can we have it closer than 100 millimeters? Is it 50 mil? Is it 0 millimeters? It depends on the scope. So in this example here, you know, between the actual wrap around the plastic pipe and the wrap around the insulation. Equally as important, the space that's required between the edge of the opening and the seals. And of course, the services themselves need to be adequately supported as well. There should be no imposed load on the fire stop seal. So these are all key things we need to be considering at an early stage, because the cost of and the hassle and the inconvenience of going back in to put additional service supports, you know, you want to be avoiding that at all costs. And finally, we need to consider, is it practical? Is it actually buildable? So yes, this is an example of where certain fire sleeves have been tested with 0 millimeter between them. Instead of 100 millimeter, they've been tested otherwise, which is all well and good. But what about from a practical aspect? If we install that fire sleeve tight to the edge of the opening and tight to each other, as we've got in this example, all well and good. But if we then suddenly decide to move them apart by 10 mil or 20 mil or 30 mil, we've then got to install batten sealant into a 10, 20, 30 mil gap. Can that be practically done? So all key considerations at an early stage. A good guidance rule, 60-40 rule, is that the services and any required insulation should not exceed 60% of the overall seal. That way you've generally got enough space. But the bottom line is the test evidence, that tested scope of application of the product or system. So as we've said, definitely not a case of, you know, a one-shot wonder. Neither is it a case of saying, well, we'll just create a hole in a wall, run everything through and hope it can be fire stopped. We need to be approaching this differently. We need to be engaging early and identifying suitably tested solutions for the application. I want to use this particular wall. I want to use this pipe, this insulation. I need to achieve this particular fire rating. Is there a tested detail available? What is the tested scope of application of that detail? Where do I need to position services to suit? And then we can go on and build. So many may be familiar with this best practice guide, very comprehensive document and put together by a number of the trade associations. It has 9 golden rules in it. And when you stop and look at this, bearing in mind this is a best practice in design and installation guide, what you'll see is that 7 of those golden rules relate to design. Now, as I said earlier, we would tend to think of fire stopping as, well, it's the fire stoppers problem. They come in at the end of the job. Lower value package, maybe later on in the program. However, this focus 7 out of 9 golden rules probably really goes to show where the emphasis and where the time and resource needs to be. It's in the design phase, and then the installation becomes much more achievable. And of course, with that comes all the benefits of keeping to program and cost benefits, etc. So not to discount any of the golden rules at all, they're all equally important, but golden rule 1 talks about an early engagement process. Golden rule 4 talks about following a design process. So again, just emphasizing really that, you know, we can't just wing it and hope for the best. We need to be planning this properly in order to get it right. So we'll talk through what a design process can look like over the next couple of slides. This is it kind of simplified into a bit of a flow chart, and we'll have that as a handout following the presentation. But really, it starts with that early engagement meeting, bringing together all those relevant parties that we've mentioned previously onto the same page, if you like, in the same room, talking about a common goal. Remembering passive fire protection, what are we doing? We're protecting people and property, ultimately saving lives. So bringing everyone together onto the same page to discuss the project requirements, and of course, to get an understanding of what you don't know. So often these other trades, if you like, plumbers, electricians, and so on, that aren't directly involved with installation, don't necessarily fully understand the complications of what their actions could be. So there is never too soon to engage and to get educated as to why we need to do what we need to do. So, of course, if we know some specifics, we can start looking at those specific installation details, but it may be too early. So how do we approach it? What does a design process look like? We need to start identifying the wants and the needs. So there's going to be certain things which are non-negotiable. Your fire ratings. And it's important to be clearer here about integrity and insulation ratings, as determined in the fire strategy. That's what you've got to aim for, and then there may be other elements which may be or may need to be slightly more flexible. You might want to use a particular wall, or want to use a particular service, or want to use a particular insulation. But if there isn't a tested solution available for that combination of products, then maybe we need to be making some compromises. So you certainly want to be making those compromises, those changes in design stage, rather than once you've started installing halfway through a project. So, as I say, conversation at an early stage about those sorts of things. And then, of course, as to how you want to create those penetrations. So some people might say, well, we're going to put everything through letterboxes. Great. Typical example that we've been looking at through the presentation already. Others might say, well, we want to try and limit it and have individual penetrations, or what we call direct seals. Again, potentially solutions for that. When it comes to floors, some people prefer to cast in fire collars. Others prefer to have a diamond drilled hole, or leave a larger aperture, which would then need backfilling with the fire protection compound. These are all great conversations to be having at an early stage as to how you want to do things. But then the question is there a tested solution which matches your wants and your needs? Now, one of the things that may dictate what you can do is the spacing requirements. As I say, an often overlooked area. And ultimately, you need that 100 millimeters between each seal, unless tested otherwise. So again, great conversations to be having at an early stage. You might want to use a direct seal, but it may be necessary to do a multi-service penetration seal in order to achieve the spatial requirements on the project. So the other complication is where we've got multiple apertures. And again, not wanting to go into too much detail, but it is necessary to touch on it, I think. If we've got multiple letterboxes, the spacing within the letterbox will be as per the tested scope. Then 1366 part 3 is saying you need 100 millimeters between the seals, again, unless tested otherwise. And indeed, some wall manufacturers may insist that you need 200 millimeters, or 310, or 330, or full studs. So again, things to be thought about at an early stage. And then if we've got services or other things tested to other standards, the requirements are that you need 200 millimeters between them. So if we put a duct or a damper in the same wall, we need 200 millimeters between the opening around the pipes and cables, is what we're talking about today, and the duct or damper. And the same would apply to things like a door, which is also tested to a standard, a different standard, and requires the 200 millimeters, and of course doors to ducts and dampers as well. So all these key things that need thinking about at design stage in order to A, achieve compliance, but of course B, to avoid that complicated and expensive rework. So how do we collect all that information? It's important that we are specific about services and installations. 22 mil heating pipe, is it plastic, is it copper, is it insulated, what's it insulated with, all these things. And yes, it can seem daunting to think, well, how are we going to collect all this information? We've got 10,000 penetrations on our project. You will have a lot of repetition. an awful lot of repetition. Once you start looking at it, you'll find that it's not as daunting as you think. But ultimately, there are sort of 4 questions, and we call this the what, and how. So we have an example here of a information collection form, which helps you to sort of condense that information at that early stage to identify suitable details. So the first what is, what substrate do we have? What are we actually going through? Is it a single skin wall, double skin wall, hollow core floor, etc.? And then, of course, what fire rating? And the important about integrity and insulation here. And then what services do we have? As I say, is it copper pipe? Is it plastic? What's it insulated with? And then the 4th one, the how, is how do you want to penetrate? So is it through a direct seal? Is it a multi-service letterbox? Once you've got that information, you can then identify the standard details. However, you may need to go out to various members of the supply chain and your contractors to get that specific information. You know, what wall is intended, what pipe is intended. So being very clear about what we're trying to do. And then from there, we can then match up those standard installation details, which are based on test evidence, to work out what can be done. And of course, the benefits of looking this at an early stage are that if there are any of those compromises or changes need to be made, that can be done at the design stage before we start installing. So it may be necessary to start a cable tray. Or, you know, in this example, we have a cable tray running through a compound seal, achieving a particular fire rating. In order to achieve another higher fire rating, insulation rating, it may be necessary to wrap insulation around those services, for instance. These are all good conversations to be having at an early stage, so that we're ready to build. So ultimately, once you've identified all those standard installation details, of course, you've got to bring them together in a workable drawing. That means reading the information on those specific details. And yes, there's a lot of information to take in, but once you get into it, you'll see there's a very consistent layout, and it all starts to become a little bit more meaningful. But ultimately, these drawings, as I say, based on test evidence, so you can see there the hyperlink for the UL classification report. The first service support requirement, in this case, within 400 millimeters of the wall, the types of services, so cables, bundles, baskets, trays, etc., and of course the corresponding maximum sizes of those services for this particular detail, and importantly, the fire rating that achieves, and the spacing requirements. So we have here an example, 0050 mil, meaning the seal can be 0 to edge, 0 to a seal of the same type, and 50 millimeters to a seal around a different service type. So we start combining all that information into a drawing, taking into consideration the size of the seal, in this case, a 20 millimeter annulus of sealant, list of the products that are required, information about the wall or the substrate, and of course, maximum aperture sizes as well. As I say, we start combining the information from those multiple details for multiple services into a workable drawing. And it's very much just a case of plodding through, working through each of the services, the size of the seal, the space that's required. So in this case, we have a plastic vent duct. We know the size of the sleeve. We know we need 50 millimeter spacing. We've then got a cable tray, which is going to have a 20 millimeter annulus of sealant around it. Because we know the size of the sleeve, plus the 50 mil, plus the 20 millimeter annulus, we now know where that tray can be in relation to the duct. And we just carry on through all the other remaining services. And from there, we can then determine what the size of the aperture needs to be in the wall. So you can see this is very much, as I say, the opposite way around to how we might have approached things historically. You know, so we might, if historically said, well, we'll stick a 300 by 200 mil aperture in that wall, and you kind of hope the services can fit in, and you hope the fire stopper can install the fire stopping in accordance with the test evidence. So as I say, it does require a change of thinking, change of process. It requires that early engagement and attention to detail. And then, of course, important to go out and check the proposals with all the relevant people. M&E contractor, is it possible to install the services in this way? Wall system manufacturer, are you happy with the aperture this size? It's all very well Quellfire saying 2.6 by 2.6 meter, but is the wall system capable of that? Fire stop contractor, can it be practically installed? And of course, finally, fire consultant, fire engineer, etc., giving you that approval. And if everyone's happy, then and only then do we commence to the build phase. So not going to say an awful lot on installation, because, as we say, a lot of the hard work during design makes the installation become much more achievable. But yes, the use of competent contractors. What does that mean? I know it's a buzzword, but we use an awful lot. Of course, the use of third-party accredited installers is a way of ensuring that the products are installed to the correct standard. And indeed, approved document B suggests that the use of a third-party accredited contractor can provide a level of confidence about the installation. And obviously, there will be certain products which probably don't lend themselves to being installed by a third-party accredited installer. Things like putty pads in electric socket boxes, there may be a case for saying, well, the electrician should do it. So a way of ensuring that the products are getting installed in accordance to those tested details is, of course, to arrange manufacturer-specific installation training. And then, you know, the age-old thing of quality control, the use of sample boards and benchmarking. We've done it for years, but maybe we haven't done it for years. So I would strongly encourage anyone to be putting those designs into reality with the use of a sample board, so that it becomes a collaborative piece that all those relevant installation contractors can gather around and see what is expected of each of them. So turn that design into reality. And of course, with that, from a project management perspective, and a quality control, go out and look. So there's an acronym for you if you haven't had that one before. Go out and look at each stage of the way. Is that plasterboard aperture, or the aperture in the plasterboard wall, created to the correct standard, the right size? If so, we let the M&E contractors in. Have they installed the correct product, correct specification services and installation in the right place, adequately supported, etc.? And yes, if yes, we can then allow the fire stop contractors to go in and install the products. So yeah, hopefully that gives you some thoughts about the installation. But as I say, passive fire protection is very complex, but ultimately it does save lives. It needs to be taken seriously, and we need to bear in mind all these complexities of the tested scope of application of the system, things like the size of the seal and the spacing that we've touched on. So yeah, if you haven't had a look at that best practice guide, definitely a bit of bedtime reading there. As I say, 9 golden rules, 7 in relation to design. And it does require that early engagement, attention to detail, following a process, following up, making sure we've got the specific relevant information to identify those standard installation details, which are of course based on test evidence, and then planning the services layout in accordance with that scope, and of course checking with all the relevant parties, and then delivering on that when we come to the installation phase. So I'm just going to wrap up by playing a little video, because we just launched this campaign here at Quailfire, just to stress the importance of test evidence. And yes, it is complex, but there are solutions available, and we have to remember that this does save lives. And the information and the solutions are readily available. There's a very comprehensive white paper, which you may wish to download. Head to quailfire.co.uk/campaign. It's a good comprehensive document covering some of the points we've touched on today. Of course, more than happy to take some questions after Rob has spoken from experience. Over to you, Rob. Thank you.
Lovely. Thank you, Craig. I appreciate that. So good afternoon, everybody. My name is Rob Hatchett. My role is Quality Manager for Ashe Group. Thank you all for joining us today. Your attendance is truly appreciated. And it demonstrates your dedication to prioritising fire safety on your projects. We understand that your time is valuable and appreciate that you've chosen to spend it with us to delve into this hot topic, no pun intended. Your attendance contributes to the collective effort to enhance fire protection measures within the industry. Craig has explained everything Quailfire, so thank you, Craig. So my part of the session, I aim to throw the process from an early engagement in design perspective, working with Quailfire, and to when and how Ashe approaches them for assistance with regards to what information is required from us so they can publish our design themes with the correct tested details. We'll look to navigate through the technical information collection form to exploring innovative techniques and easy to read details. My aim is to show you how Ashe tried to get this right first time, which will hopefully equip you with the knowledge needed to enhance the fire safety measures on your project. So with thanks to GIRI and Quailfire, I believe this webinar will deepen your understanding of passive fire stopping principles to empower you in implementing the correct fire stopping detailing. First and foremost, early engagement allows us to compose a comprehensive fire risk assessment and tailored fire safety strategies to be integrated into our project's design. This is a proactive approach enabling our designers, with the assistance of fire engineers, to assess fire resistance requirements and investigate fully compliant tested fire stopping detailing and develop, if required, customized passive fire stopping protection solutions that align with the specific needs of the building. Involving fire safety experts and passive fire stopping specialists early on fosters collaboration and knowledge sharing among our industry. This collaborative approach facilitates integration of the fire protection measures into architectural and structural designs, ensuring that passive fire stopping elements are seamlessly incorporated without disrupting the overall aesthetic or functionality of the building. Additionally, early engagement enables us to anticipate and address potential challenges or conflicts related to passive fire stopping implementation before they can escalate into costly delays or rework during the construction phase. By proactively identifying and resolving the issues upfront, project teams can optimize efficiency, minimize risk, and maintain project timelines and budgets. So, with all that in mind, Ashe contacts Alec Purdy or one of the Quailfire technical team to ask what information they require from us to be able to produce the information and details specific to our project requirements. Our design team can then incorporate those into our design. The Quailfire team will respond in a timely fashion and will request our design team fills out the technical information collection form. This form identifies all key considerations for Quailfire to publish Ashe with tested detailed scenarios. The information requested on the form consists of what fire rating and installation integrity is required, for example 30 or 60 minutes or more if required, what substrate type the seal is being fitted to, be it a single or double skin flexible wall, rigid blockwork, plasterboard ceiling, concrete floor, hollow core floor or metal deck, what wall build-ups are being used, for example, two number 15mm fire rated plasterboards, both sides of a 50mm stud with an overall width of 100mm. Which service type is going through the firewall, for example, a plastic pipe, insulated metal pipe, uninsulated metal pipe, plastic vent ducting, electrical cable trail basket, trunking, or any conduits containing cables. It then requests the outside diameter or the size of the service excluding any pipe installation. Also, it requests the thickness of any installation then to be added, and what type of service penetration is to be used, whether it be a single penetration, direct to wall seal, or whether it's a multi-service penetration fireback seal, or ideally a formed letterbox opening with a framed and lined aperture. It also has a bottom box for any comment should you put anything in there. The Quailfire team will also send over the Quail Selector, which is a standard installation detail selector tool as a handy PDF guide that you can keep on your laptop with all details readily available. This document is broken down by substrate construction and then by penetrating services, so it is easy to navigate. This is a great tool for our design teams and site project managers, as it's a quick and easy way of identifying a tested passive fire stopping detail should they require one. Once the technical team at Quailfire have reviewed the key considerations in the technical information collection form given by our designer, a team's meeting then takes place to discuss the provided technical information. It's discussed collaboratively that specific details can be used for single skin walls, double skin and blockwork walls, but for single skin walls, different details are used in conjunction with other details, which is where it gets complicated. So, for cables, cable bundles, cable baskets, cable trays and cable ladders in a double skin wall build-up, we would refer to detail QB FW100 DO1 as shown on the slide. This detail dictates that the first service support is required to be under 400 mm both sides of the opening, and then the next service support be it as per any other manufacturer's recommendation for the application. The minimum distance from the edge of the fire stop seal to the edge of the aperture can be 0 mm. The minimum distance from the edge of the fire stop seal to a service penetration of the same type is 0 mm, but the minimum distance from the edge of the fire stop seal to a service penetration of a different type should be 50 mm. A common issue that we've found with our supply chain, not so much now due to supply chain workshops and upskilling our workforce, but the knowledge of the specific requirement of the first service support. It is imperative that the service supports are installed as per the detail, as this is how Qualfire have tested that application. If the service supports are not fitted as per the detail, in the event of a fire situation, the seal will not be compliant to the tested data. This information can be taken on board by our design team, and a robust project-specific design can be composed. Incorporating passive fire stopping information into our projects due to early engagement offers a multitude of benefits that positively impact the integrity, safety, and efficiency of our projects. As mentioned before, early engagement allows us to identify and address potential fire hazards and risks upfront, ensuring that our design prioritises the safety of the building occupants and its first responders. By implementing the robust passive fire stopping solution, we create a protective barrier that helps contain fire and smoke, mitigating the spread of flames and reducing the risk of injury or loss of life if required, building protection. We can also ensure compliance by collaborating with our fire safety experts and passive fire stopping specialists early on. We can ensure that our design meets all relevant building codes, regulations and standards related to fire protection. This proactive approach minimises the risk of compliance issues arising through the construction phase, avoiding costly delays and rework. We can also ensure we keep the QSs happy by minimising the costs by addressing passive fire stopping requirements early in the design phase. We can identify cost-effective solutions that deliver optimal fire protection without exceeding budgetary constraints. And this proactive cost management approach helps minimise unexpected expenses associated with retrofitting or remedial work later in the project lifecycle. In summary, incorporating design due to early engagement offers a range of benefits, including enhanced safety, regulatory compliance, efficiency, aesthetics, and cost effectiveness. By prioritising fire protection from the outset, we lay the groundwork for a resilient, high-performance building that meets needs of both its occupants and its clients. Thank you very much.
Thanks very much, Rob. That's very substantial bit of information we've garnered there from Craig and Rob. And we have some questions in our chat. I'd just like to start us off with a sort of general query that Craig or Rob can answer. You show a lot of examples of the use of services going through a single opening with BAT. Is that a preferred way of doing it, to drilling having individual holes for each service? Leaving service openings in walls for a specific service. Is there a preferred way of going about that?
So the simple answer is that if there is a tested solution for doing it directly through a wall, then you could do that. And indeed, we at Qualfire have many details for what we call direct seals. But the key thing, which I kind of touched on, is the spatial coordination. So if you were putting individual holes through walls, 1366 says that you need 100 millimeters unless tested otherwise. And generally, manufacturers wouldn't test closer than 100 millimeters in a direct seal. Whereas in a fire bat seal, we would test closer. So, we had a look at some of those examples where between certain different services, you've got just 50 millimeters, between services of the same type, 0 millimeter. And of course, it is normally common in modern construction that we have lots of services trying to go through a small area. So, which is why fire bat seals tend to be more popular, especially where we've got a lot going on. But there's, both ways are right as long as there is a tested detail for that specific application.
Okay, and so when we're going down the bat solution, what's the installation sequence then? Do you put some bat up and go through it, or do you put all the services in and then bat around them?
Yeah, normally the opening would be created in the wall. If it's a fire-rated flexible plasterboard wall, the services would be installed, and then the fire bat would be installed around the services. So whilst the bat is supplied as a 1200 by 600 mil sheet, it would then be cut and fitted around the services.
Okay. Okay, thanks for that. Have you got any comments on that, Rob?
No, my comments would mirror Craig's, honestly.
Okay. I didn't know whether, as the contractor, and obviously Wellfire provide a lot of support and advice, but I just wondered whether you'd got a preferred contractor's approach. Anyway, we've got a question here. How is fire stopping matching the movement or deflection of the building? What's the how, if there's a bit of movement, how does that affect the fire stopping?
Yeah, it's a great question, and it is something I didn't touch on in the presentation, but that is also one of the key things that needs to be thought about at that design stage. So obviously the fire-rated plasterboard wall systems would normally incorporate a deflection head into them.
Right.
If you are then breaching that deflection head by installing what we call a three-sided letterbox with effectively the bat seal touching the underside of the slab, then you've got to reintroduce that movement. So again, there are tested solutions available using fire bat and a compressible linear gap seal, for instance, but it's again one of those key things that needs to be thought about at an early stage.
So it's basically a design issue then.
Yes, exactly right. It needs to be thought about in the design phase, yeah.
Here's one then. This is from Lee. What are Craig and Rob's views on the risks of builders work in connection and passive fire protection being let as CDP packages, putting the onus on the subcontractor often after key decisions have been made? Should the principal contractor be resisting key packages being reliant on CDP subcontractor and ensuring the consultant design team deliver up to stage 4? Well, can I just say, I had 38 years as a contractor. It's not so much the contractor that can force the consultants and designers to do more than they've been contracted to do from the client in the first place. So there's a lot more to this than the contractor resisting, because if they resist too much, they don't get the job. So there has to be a balance here. What's your thoughts on that, Rob?
I think that the consultants and the design teams need to take a collaborative approach and work on it from an early engagement point of view. I think if everyone's on the same packet on the same side, then I don't see why these bits can't be worked out between them. Again, if the M&E consultant is on quick enough, then the service routes and spacing, that could obviously be sorted out. I think the early engagement part of that is the key.
But does that not have a commercial risk associated with it, which is why it's resisted?
Absolutely, but I think the mitigation that you make up front will certainly mitigate what would potentially happen downstream should you not have done that.
So the early engagement is actually commercially advantageous because you have a better outcome. Yeah,
because you're not making builders work holes 3 and 4 times, to suit a subby. It's all done in the design in the first place. Right.
Okay. Hopefully the design's advanced enough to be able to finally position the holes through the various structural elements. Right. So In Rob's opinion, should designers be prioritising encasement of steel structure or applied intumescent coating as best practice?
This is 6 of one, half a dozen of the other. Obviously, you can encase beams externally, but then you've got weather and stuff that may or may not have an impact on that. I think that intumescent plates certainly has its value. From my opinion, I would rather encase everything than paint it.
Okay, well, I suppose again there's a certain commercial and timescale issue there, isn't there? So we have our preferences, and then we have to work with the space we've got.
Correct.
But it's good to have a clear idea of what you're hoping for. Certainly the temporary works access is also, and scaffolding access is an important factor there as well, isn't it? So
again, with that early engagement with the plasterboard people, whether they're putting ProMat on or whether it's a BG detail or anything like that, a lot of these things, they can be overcome before they get to site.
Great. We've got one here for Craig. Do Quell Fire provide 3D models of proposed fire stopping, including asset information and data, or the capacity to check those provided by the consultant design team?
So we do have BIM objects for the individual components, but as we probably highlighted in the presentation, it's very much it's a job to bring all those BIM models together. So yeah, we have the basic 3D models. In terms of the checking, we're more than happy to sort of have an oversight of what has been proposed, check it's an accurate interpretation of our data. We would normally go through a BIM model through every single penetration node, but if you've got cross sections, we're more than happy to look at them and provide commentary on it.
Great. On the you both refer quite considerably to the term as tested, or proved by tested, or whatever it is. So who actually does these tests? Is it the BRE or something like that, or are they can you go privately and get tests done?
Yeah, so the product should be tested to the correct standard, which surface penetration seals BSEN 1366 Part 3, as I've referred to, and they should be tested at a UCAS accredited laboratory. So there are a number of them. Typically here at Quell Fire, we tend to use Warrington Fire, Warrington Fire. They're just half an hour up the motorway for us, and one of the, I suppose, more established names when it comes to service penetration seals. But the important thing is the classification reports. As I say, that tested scope of application of the system. So again, that data is classified into a classification report by, again, another UCAS accredited laboratory. So we would again use Warrington or UL or others. So yeah.
So it's possible that when one is in the design stage and you've got your various pipes and wires going through whatever it is, it's possible to get some advice and then have a test done on that, is it?
Theoretically, it is possible, but given the timescales involved, probably not, and that's the whole point. So to book a fire test and to obtain the test reports and the certification, you take months, if not 12 months. So that's the whole point.
It could take a very long time to get a non-standard or something that a product manufacturer hasn't already got. So in my sort of BBC voice, because we're not allowed to advertise, that there are other products available, but the fact remains that you've got to find a product that's got the appropriate BSEN 1366 accredited stamp if you want to use a standard detail and save yourself the 12 months of getting a test. I know that we've talked mostly about passive fire protection because that's the subject of the webinar, but there's all sorts of other aspects of a fire resistant wall, including, you mentioned, doors, and they have to have their accreditation, if you like, for 60 minutes or 30 minutes and be installed correctly. So this whole subject goes, as you said in the earlier part of your presentation, Craig, it covers the whole issue: floors, ceilings, doors, windows, presumably. So yeah, it's a very broad subject. Now, timescale for full-scale tests currently 6 months, Lee's saying, and they cost in the region of £30,000. So thanks for that information, Lee. That's just popped up in the chat. Thank you. So I'm not seeing any other questions coming through at the moment. I do think we've covered a lot of ground today, and I think that Craig and Rob have, certainly in my mind, clarified a lot of the issues that it's important to consider when you try to get your passive fire protection right. And getting it right is not just about the importance of the commercial aspects and rework and safety that we mentioned earlier, but it's also very much about saving lives. And I think that's one of the principal reasons why I felt it would be a really good idea to run this webinar, because we mustn't lose sight of the fact that doing fire protection properly saves lives. So thank you very much to our speakers, and thank you very much to those who have attended. The slide summary will be made available by a link, and we have recorded this session, so it will be available on YouTube in due course, the GIRI YouTube channel. And in fact, if you do go to the GIRI YouTube channel, he says, easy for you to say, then there is a lot of other very useful information. And also the GIRI Knowledge Centre is populated with quite a lot of good information and background on the Building Safety Act. So thank you very much, everyone, and hopefully you'll join us for our next webinar next month, which I can't remember the title of. I don't know whether you can, Susan, but we are doing another webinar with Rob in a couple of months' time. Thank you very much.